Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.72. While solving this problem, we will be using current divider rule. Basic equations for the calculation of currents I1 and I2 of this particular circuit using current divider rule is provided here. Now move towards the problem. Exercise problem number 2.72. Find current I0 in given below figure. This is the circuit diagram of given problem. We have to find the value of current I0 through this branch inside this network. So without wasting time, let's proceed towards the solution. If we observe, we are interested to calculate current through this branch only. So we will try to simplify the network in left hand side. Start from here. These two resistances are connected in series connection. Find their equivalent resistance by adding the values of both resistances together and replace these resistances with their equivalent resistance. Sum of these resistances will be equal to 16K. So modify the circuit by replacing these two resistances with a single resistance having the value of 16 kilo ohm. Now these two resistances are converted into parallel connection and both have same values. So we will use this equation to calculate their equivalent resistance. In this equation, R is the value of a single resistance and N is the number of same resistances connected in parallel connection. In this case, N will be 2 and R will be 16 kilo ohm. Place values inside this equation. R equivalent is equal to 16 kilo ohm divided by 2. R equivalent will be equal to 8 kilo ohm. Modify the circuit by replacing these two resistances with a single resistance having the value of 8 kilo ohm. Now these two resistances are converted into series connection. Find their equivalent resistance by adding the values of both resistances together. 8 kilo ohm plus 4 kilo ohm will become 12 kilo ohm and replace these two resistances with a single resistance having the value of 12 kilo ohm. The circuit is simplified, but we will reduce the circuit further so that we can calculate total supplied current through this branch. If we succeed to calculate the current of this branch, we will be able to apply current divider rule on this circuit to calculate the current of this branch as well. But for that, first we have to simplify this network and calculate this total supplied current. For that purpose, we will take the equivalent resistance of these two parallel connected resistances using this equation. R equivalent will be equal to R1 multiplied by R2 divided by R1 plus R2. In this case, R1 will be 12 kilo ohm and R2 will be 6 kilo ohm. Place values inside this equation to calculate their equivalent resistance. Product of 12K and 6K divided by the sum of 12K and 6K. Product of 12K and 6K will become 72K square divided by the sum of 12K and 6K will become 18K. 72K square divided by 18K will result 4 kilo ohm. So now we can replace these two resistances with a single resistance having the value of 4 kilo ohm. Now the circuit is simplified. At this stage we can calculate total supplied current through this voltage source. Current of this voltage source can be calculated using Ohm's law. I will be equal to V divided by R. In this case V will be 12 volt and R will be the total resistance across this voltage source. In this case the resistance will be 4 kilo ohm plus 2 kilo ohm. Because both resistances are connected in series connection and their sum will be equal to total resistance connected across this voltage source. So equation of I will be equal to 12 divided by 6 kilo ohm. Divide 12 with 6 kilo ohm, the value of current I will be 2 milliampere. And the direction of current will be clockwise. This current will be leaving from positive terminal of voltage source and entering from negative terminal of voltage source. We can say that this same current will be also flowing from this resistance in this direction. So we have calculated current through this 2 kilo ohm resistance. We can place this current along with its direction in original circuit. The current through this 2 kilo ohm resistance in this original circuit will be flowing in this direction. Now we have total supplied current through this branch. We can apply current divider rule to calculate the current of this branch as well. For that purpose, we will label these two branch currents as current I1 and current I2. We are interested to calculate current through this branch, so we will take current I2. Current divider rule equation for I2 will be R1 multiplied by IT divided by R1 plus R2. IT is total supplied current. In our case, it is 2 milliampere. R1 is the resistance of opposite branch. In this case, it is 12 kilo ohm. And R2 is the resistance of same branch, that is 6 kilo ohm. Place values inside this equation. 12k multiplied by 2 milliampere divided by 6k plus 12k. Product of 12k and 2 milliampere will become 24 only. Milli will cancel out with k. And sum of 12k and 6k will become 18k. Now divide 24 with 18k. Value of I2 will become 1.33 milliampere. Now this 1.33 milliampere current is flowing from this branch in this direction, because total supplied current is entering on this node and it will leave from these two branches in this direction. So the direction of current I2 inside this branch is upward, while the direction of current I0 given in scenario is downward. Here in this branch, I0 is equal to I2 because of same branch but opposite in direction. So the value of I0 will be equal to minus 1.33 milliampere. This minus sign along with magnitude is indicating that I0 is taken with wrong direction inside this network. The actual direction of current through this network was opposite to the direction of I0. So this was exercise problem number 2.72. Thank you. See you again in next video.